Hey guys, the last time on 2.4 we learned the last two formulas in order to take like the derivatives in the easy way. Those are the product rule and also the quotient rule, right? Personally, I don't think they are super hard. I mean, it's they have like 3 steps, right? First step, we have to identify which one is f and which one is g. Second step, we have to take the derivatives for f and g, and then third step, we have to base on the formulas in here. Say if you're gonna have like a product in here, then you have to use the product rule and use this formula in here. And then if you have like a fraction or a quotient rule, you have to use this formula in here for the quotient rule. Okay, so it's like you have to pick on the right formula and then piece everything together, and after that just simplify, do the algebra for it. Okay, and on top of that, make sure we also have like the previous like formula in 2.1 and 2.2, right? We have the constant rule, the power rule, constant multiple rule, and then sum and difference rule. Okay, and then the very like technique that we used on the last time to help us get the quotient rule and then the product rule down is the chain rule. Okay, so today I promise you guys I'm gonna talk about the chain rule more specifically. Okay, okay, let's talk about this. So in this section we'll study one of the most powerful rules of the differential calculus, the chain rule. We actually like talked about it, but today we're gonna talk about it like more in depth. Okay, this differentiation rule deals with composite functions and adds versatility to the rules presented in 2.2 and 2.4. Okay, composite function in the sense that you have to use a u function in here. So if you remember the ping table or like the method of the chain rule, we have the inside and outside, right? Those are actually the composite functions. Okay, but if you don't understand that like the composite functions in there, that's okay. Like I'm not gonna test you on the name. Okay, so as long as you know which one is inside and which one is outside, if you know how to take the derivative of each of them and then multiply them together, that's what I'm asking for, and that's good enough. Okay, so now let's talk about the only objective that we have for today, the chain rule. Okay, so again, we're gonna have some problem for my part in here. I have find the derivative of the following function, right? So for my part in here, first of all, I told you guys that I don't like it to, well, I would appreciate it to have like everything written under the root form, right? But this one is like, it's really hard to deal with because we don't have any formula to do with, you know, the square root or like any root. So we're gonna have to rewrite it as the fraction exponent. So in this case, it's gonna be like 3x squared plus 5x minus 1 all to the power of 3/4. And again, this is like inside divided by outside. Okay, and okay, so this in here, the chain rule in here, if you want, you can understand it. If you don't want to, you can always do the inside and outside method. Okay, okay, let me highlight the inside and outside in here for you guys. Usually I do inside for blue and outside for green, right? Just like the last time. So inside in here, if you know this is inside. Wait, highlight. This is inside, right? And then that refers to the derivative of the inside, right? And then on the outside layer, we have f prime in here. And then at the end, we multiply them everything together, right? So let me circle the multiplication technique in there. And then again, like you don't have to understand like from word to word what the formula says in here, as long as you remember like there's 2 layers, right? We have the outside layer, inside layer. We have to identify which one is which. After that, we'll take the derivative of each of them and piece everything together. Okay, and the big thing in here is that make sure you only have one variable. Okay, you cannot have both x and u. Okay, that's a big no-no. Okay, whenever you have a u in here, make sure you always convert back to x. Okay, so make sure you don't have u on the final answer. Okay, like at all. If you do have u on the final answer, make sure you double check on your work because it's wrong. Okay, and I talked about this already. We always gonna have like inside and outside function. That's easier for me at least to think about it. And then for my personal tips, we have we apply chain rule when the function is not just a polynomial, i.e. like in other words, when a function has like shared exponent. What do I mean by shared exponent? As you can see, like this exponent in here is for the first term, is for the what is it? It's for the 3x squared, it's also for the 5x, and it's also for the 1, right? So it's a shared exponent. It's not like the exponent of any one in here. It's for all of them, okay? So for example, if I have like this exponent in here, or like this exponent in here, like the fourth root in here is shared for the 3x and also for the -1. This exponent here is for the 1 and also for the 5x fifth. And then this 3 in here is for the first term, second term, and last term in here, and so on, right? Like we have many more examples of the shared exponents, but technically whenever you have like a shared exponents, we have to use the chain rule, okay? It's always there for us to use when it's like comes to a shared exponent, okay? We call the functions the power function. Okay, so these are the example of the power functions, and because, well, we have the power, right? That's why it's like power function. Easy name, okay? So let me take some of these out so that we have, in general, this is a form of the power function, okay? Like anything that has a power, if you know this part in here is the base, and this n in here is the exponent. This is like refer to what we learned from the exponential function and also the log function, if you remember, the base and the exponent. So essentially whenever you have the exponent function, whenever you have an exponent, we refer to them as a power, okay? So let's get back to what we had for our example. So first, we're gonna rewrite this formula in here by the exponential form. And then that gives me like a 3/4 in here. And let me take out some stuff in here before I move on. So you get that. Okay, so now next step, identify the inside and outside layer, right? So inside I'm gonna get, let me highlight in blue again for the inside, and for the outside I'm gonna get this, okay? So inside here I have u equals to 3x squared plus 5x plus 1, okay? And then for the outside I have u to the 3/4, okay? Next step, I'm gonna take the derivative of both of them, like 2 boxes in here. For this one, in short, I'm gonna get like 6x plus 5, okay? And again, if you don't know why I got like 6x plus 5, make sure you do more examples and more practice problem, and you can always reach out to me. It's just like you have to apply like a lot of like rules from the previous sections, okay? And then when you get like a hang of it, it will be fast, okay? It will be like just, you know, like within a second, take it down, okay? And then similarly, for the second box, I'm gonna get like 3/4 in here, and then if I minus it by 1, I'm gonna get negative 1/4, okay? And if I rewrite it, it's gonna look like 3 in here, and then 4, and then the cube root, 4, the 4th root, my bad, 4 root. And then because we have a u in here, right? And then I told you guys it's weird to have like u in the answer, so instead of having this u in here, I will go ahead and replace it by this, because u's is actually 3x squared plus 5x plus 1, right? So let me go ahead and stuff all that into the square root, or the 4th root in here, 5x plus 1, and extend the 4th root a little bit. Okay, now I'm gonna go ahead and multiply this with that, just like the last time, right? So with that, I have 6x plus 5 over 1, and then again at top times top. So I have 3 times 6x, which is 18x, and then 5 times 3, I have 15. And if you don't know what I'm talking about, I'm doing like FOIL for this and for that, okay? And for the bottom part, I'm gonna multiply the 1 with like everything, okay? And we all know that 1 times anything would be just that anything, right? So this whole thing would be over 4, and then the 4th root of 3x squared plus 5x plus 1. And again, to double check your final answer in here, make sure you don't have any u in here. If you do, it's wrong, okay? If you do have a u in here, make sure you substitute it back to this step in here, because we do have a u, okay? And this is our final answer, okay? Like this is it. And I just realized I make a mistake again. So this one is a -1, not a +1. So that's a -1 right there, and then this is also a -1, and this is also a -1. But luckily for me, it doesn't affect anything. Okay, so that's just there, okay? And then let me put a green star for your part. This is what you have to do. And then this is not like an objective for the day, but it's just like a summary of, you know, what we have in terms of all the differentiation rules. This is something for you guys to print out in terms of, you know, like homework or exam or even test, okay? So general power rule in here, technically you're gonna have to like do the power, you can ignore this rule if you want to, and think of it just like a combination between the power rule and the chain rule, okay? Like this is what we apply already, and I don't want to teach you guys like the stuff that you don't need to. I don't want to confuse you guys, so if you want to, you can ignore the general like power rule. It's written in the textbook if you want to read it for more information. But I believe that if you know the power rule and if you know the chain rule, you can just use them to get the general power rule. Okay, you don't have to learn the extra thing in here. Okay. So again, we have like the old friends in here, like everything in here, they comes together with the chain rule. So make sure whenever you have like the inside layer, you always have to use the chain rule, okay? And then my personal tips in here, note that when we simplify our work, make sure that the final answer has no negative power, right? And then also the common factors, so I'll factor out. And the fraction looks proper, okay? So negative power, I mean like if you have something like u to the negative 1/4 in here, make sure you turn it into, you know, like 1/4 root of u. Okay, like this in here will be an acceptable answer, while this is not an acceptable answer, okay? And then for factor out, say for example, if I give you something like 2x plus 4 in here, I mean like it's okay to keep it this way, but I would refer it if you guys factor the 2 out, and then this one would be like, to me, a proper answer compared to the other one, okay? So I would go with this one rather than this, okay? But either one would be fine for me. Like if you were in a rush in the test, either one would be a good answer to me, okay? But definitely no negative exponent, okay? No negative power. That's a big no-no, at least for my class, at least for this class, okay? And lastly, the fraction looks proper, okay? So this is what I mentioned when we talked about the quotient rule in 2.4. If you have like a 3-part fraction, make sure you simplify it down because it doesn't look like a proper fraction. Okay, for example, if you have, I don't know, like x divided by 2, and then you have a 1 in here, and then all divided by 3. If you know this, we have like 2 things in here, and then we have like a 3rd thing in here, right? So this is not proper at all. This is not proper. Okay? Take this out. And again, how can we not make it proper, right? Well, we have to find a derivative. No, we have to find a common denominator for the top part in here, and then we're gonna just do it out. So the 1 in here can be rewritten as 1 divided by 1, and then we're gonna multiply it by the common denominator, which is 2 in here. And after that, let me write in here, we're gonna get something like 2 divided by 2 plus x divided by 2, everything over 3, right? And this is 2 plus x divided by 2 divided by 3, because the 2 in here is on the bottom and the 3 is also on the bottom, so they will be together on the bottom, okay? So it's going to look like 2 plus x divided by 2 times 3, okay? And make sure you don't leave the answer as this one, okay? Because we all know what 2 times 3 is, right? 2 times 3 in here, it is 6. So make sure you put a 6 in here, and that will be a proper answer to me. Okay, so this is what I mean by proper, okay? So factor or no, this is acceptable. I can reconsider about it, but definitely no negative exponent and proper, and your fraction has to look proper, okay? And this is all about 2.5, okay? So for this one, again, for 2.5, you only have one thing to do, okay? Like this is the only task that you have, okay? Thank you for your listening. If you have any questions, let me know. Take care and have a great day, okay? Bye.